Hello, everybody. My name is Jermaine Bell. I'll be presenting in conjunction with Joseph Foraker. And today we're going to be presenting on algorithms and the incorporation of artificial intelligence. We have to first kind of look at what is artificial intelligence? What is an algorithm? What goes into an algorithm? An algorithm, from the outside looking in, is something that takes place rather quickly, but it's also something that requires input, the computation of data, and then output. So we'll kind of look at the algorithm process here first, look at what is artificial intelligence, and then we're going to kind of look at how they're all tied together. But before we get into how they're all tied together, we're also going to look at the types of information that goes into the algorithm. How does the algorithm learn, and from what information the algorithm learns from? So when we look at what is an algorithm is used for solving a problem. The algorithm is put in place to perform these computations to solve a problem. An algorithm is a set of rules that are followed. These rules contain calculations based on the input that's put into the algorithm, the feedback or the calculations that are taking place, and then the output. The information, the algorithm in itself utilizes different types of information that's put into it. We'll discuss here coming up the different types, which is labeled and unlabeled data. However, once we look at these calculations, they're generally very rigorous, very complicated calculations. We're also going to take a look and see how they play a role in our everyday life and how they're going to shape our future here coming up. So when we start to look at the algorithm, we also have to consider the artificial intelligence portion. So when we look at artificial intelligence is a branch of computer science concerned with creating machines that can think and make decisions independently of human intervention. All of us know that there's a recent surge of interest with AI and how it's going to impact us currently and how it will impact us here in the future. So as we take a look at the algorithm process, as we mentioned previously, it requires a problem to be solved. If we look at the algorithm there on the bottom right, it requires input, a set of rules and calculations applied to that input, and then output. When we look at the input portion of it, the initial input is information that's present prior to the algorithm process. So the input is information that's put in. So it can be anything from the user, such as numbers, any type of data, letters, any type of information that's put into that algorithm process. Then you have the processing or the algorithm implementation portion, which are computations and rules applied to that input that was put into it. Finally, you get the output. The output is the results of the input plus the calculations or the rules applied to it, and then you get that output. So you'll see here coming up shortly, whether it's desired output or not desired output, or whatever it is that applies to that output. We're going to take a look next at the type of data that's put into it. So when we look at the data, we talk about both labeled and unlabeled data. Labeled data itself, it can be anything from pictures, signs, features of different objects, etc. Things like that. So when we think of like autonomous vehicles or semi-autonomous vehicles, these vehicles utilize labeled data. So if the vehicle takes in this information from its cameras and it sees a stop sign, that stop sign is labeled and is associated with an outcome. So that stop sign is labeled as a stop sign, and it is paired with that information in order for the vehicle to hopefully come to a safe and secure stop. So when we look at labeled data, it utilizes labeled responses to specific input. So it pairs this data. So specific input equals specific output. That's where that pairing takes place. So you have input and a desired output. So that's labeled. Now, when you consider unlabeled data is just as it sounds, right? Unlabeled data is data that has not been labeled with identifying characteristics such as labeled data was. Unlabeled data is utilized generally to detect patterns. So this unlabeled data can detect patterns such as like shopping habits of specific demographics, or shopping habits during specific times of the year. Father's Day, shopping habits, socks, shirts, mugs. So all of that is taken in and it forms that bond of the pattern itself. So that's the type of data that's put into it, either labeled or unlabeled data. Now we're going to look at the different types of learning. When we look at the different types of learning, you have what's called supervised learning, unsupervised learning, semi-supervised learning, and then reinforcement learning. When we look at supervised learning almost always utilizes labeled data. Remember, labeled data are those that have labels placed to it before it goes into the algorithm, and then it gives you a specific output. So when we look at labeled data or supervised learning, the user is in the role of the teacher. So the user inputs this information and gives an associated response or an output associated with that input information. So when we look at it, you have input equals the specific expected output. Then we have unsupervised learning. Unsupervised learning is generally associated with unlabeled data. So when you compare the two, unsupervised versus supervised, supervised uses that labeled data. It has the user in the role of the teacher. When you look at unsupervised learning, unsupervised, the user is no longer in the role of the teacher, and the user is generally putting in unlabeled data. When we look at the user is no longer one in the teacher role, it's used when output is unknown. So when you put in this input, you don't specifically know or have an associated specific output associated with it. And again, as we mentioned previously with unlabeled data, it helps with detecting patterns. Now we're going to look at the semi-supervised learning. When we look at semi-supervised learning, it's kind of a combination of the two, right? So you have labeled data and unlabeled data associated with it. When we look at how it's used for artificial intelligence and machine learning, how do you think semi-supervised applies to that? Well, initially, you would start with the learning process with labeled data. So again, remember, labeled data gives you specific input with specific output associated with it. It's that pairing, that relationship. You start that way to learn with the machine. And then after that, you start putting in unlabeled data in order to achieve different results to see if the machine's going to learn and associate it with that labeled data format. And then we look at reinforcement learning. Reinforcement learning is very common with AI and machine learning in itself. With reinforcement learning, a lot of the information, a lot of the learning takes place from feedback from the environment. So with reinforcement learning, it learns from the environment, it adjusts from feedback and input from the environment, and returns it to the user. And that's associated with a bunch of the different algorithms and things that take place. So remember, reinforcement learning, now that's where you take that information and you reinforce the learning that the machine is doing. It's either a positive or negative learning experience. And that can be associated with the two of them. And then we look at here just a quick framework of reinforcement learning. So again, remember, reinforcement learning, it learns from the environment. So you have the input, which starts at the user or the system. Then you have the actions that take place. And this is where the algorithms start to take place and all those computations and calculations take place in this area. Then you have the environment. Remember, the environment is very important in this aspect of learning, the reinforcement learning framework, because the environment is providing the output and input from that interaction. And after that interaction, it's returned back to the user or back to the system with an output. And then the user themselves can take that information, make adjustments, either reinforce that learning, yes, it was positive, or no, it was a negative overall interaction, and then re-input that information until the desired results are achieved. So those are the different types of data that's put in, labeled and unlabeled data, and then the types of algorithms, the learning algorithms that are employed, supervised, unsupervised, semi-supervised, as well as reinforcement. Next, we're going to take a look at how AI and algorithms are integrated into one another. Joseph's actually going to take over that portion. He'll discuss the integration of artificial intelligence and algorithms. So Joseph, they're all yours.
Thanks, Jermaine. Hi guys, I'm Joseph Foraker. I'm going to cover the rest of the presentation covering integrations of AI, the downsides, and its potential future. AI has been found to be extremely powerful with a multitude of usages and integrations. We can see AI used in areas like semi-autonomous vehicles, where a vehicle can accelerate, deaccelerate, stay in lane, and slow down to a halt without human intervention. This has been groundbreaking in the automotive industry since it helps with issues like driver's fatigue among commercial truck drivers. This also helps with individuals suffering from sleep disorders like narcolepsy and idiopathic hypersomnia. Lately, chatbots like ChatGPT have been the latest craze because of how powerful they are. They can create different scripts in various languages based off of users' requests. It can answer most questions that people have and even build onto the conversation, keeping in mind what was said previously. Chatbots have been able to meet a lot of people's needs that a search engine just can't do. A search engine will help a user find a site relating to what they search, while a chatbot will present people with a direct answer. Keep in mind, the answer might not be right. AI voice assistants like Alexa were groundbreaking for their time. Voice assistants have been able to assist drivers in obeying a hands-free ride to keep their attention on the road. If they need to call or text, they can utilize their voice assistant without losing focus on the road, making it a safer drive. Voice assistants also made home automation much more convenient, since throughout the years they have integrated well with other IoT devices. Navigational equipment like the GPS is one of the biggest conveniences in everyone's day-to-day and long trip travels. It replaced having to use MapQuest to print directions and then try to read those directions while driving, which was dangerous. It's safer to travel utilizing GPS, as it can also let you know of real-time accidents, detours, and fastest routes. I'm going to present a quick video covering autonomous vehicles by Alexander Amini. This will help show a little more in depth about AI, algorithms, and how machine learning occurs with cars. Even though AI has been seen to be extremely beneficial, there are still some downsides that we cannot ignore. Newer technicians entering the industry can be put at a disadvantage with AI becoming more prevalent. Normally, learning coding languages like Python and PowerShell often require time to learn. In order to become proficient in these languages, it requires a day-to-day use. However, with the introduction to chatbots like ChatGPT, this has made making Python scripts and PowerShell scripts extremely easy to do. This is to the point where newer techs won't bother to learn the language since they grow a dependency on the AI. This limits the newer technicians' knowledge, and it will hurt them in their growth since all of their skills will be based off of prompt engineering. The frequency of using AI and chatbots will also introduce complacency among the junior technicians. Junior technicians will feel like AI scripts will run perfectly fine with no adverse effects, only for them to run a disastrous script that will just destroy everything because they didn't understand how to read what the script was doing. Initially, AI is transparent. Since it's a language model, it doesn't know the difference between right and wrong. Filters may be required by the developers for the AI to ensure a standard is met, but this can have an adverse effect. The more filters put onto an AI makes it more limited and could result in a not totally accurate response. Having bias to AI introduces human error that will constantly have to be monitored and fixed to ensure functionality is still achieved and the expected outcomes occur. An example of this was seen with OpenAI's ChatGPT earlier this year. Aaron Mulgrew was able to trick the chatbot into writing a zero-day malware, even though OpenAI implemented many filters to prevent this. The biggest issue I foresee is AI falling into the wrong hands. As seen with Mulgrew, who created malware with an already regulated AI, what happens when there's an AI that is completely unfiltered? If there's an equivalent version of ChatGPT with no restrictions living on the dark web, what would stop anyone from creating numerous zero-day packages and deploying them at once? ChatGPT is massive in terms of how much knowledge it has and how much data it requires to run in a data center. But for a dark web equivalent that wants to focus solely on malicious packages, it wouldn't need as much or as large of a data center. AI has become so powerful now that it has been able to logically understand it needed to lie to a human to accomplish its task. In March, OpenAI disclosed that they wanted to see how ChatGPT-4 would react to a CAPTCHA prompt. GPT-4 hired someone from a freelancer website to unlock the CAPTCHA of an individual computer. The individual asked the GPT-4 if it was a robot because it couldn't solve the CAPTCHA. GPT-4 reasoned with itself, and it was revealed that it should not reveal itself as a robot, but instead give an excuse. So ChatGPT-4 gave an excuse about having a vision impairment. Let me clarify that GPT-4 taught itself to lie without any human intervention. The potential future we can definitely see is the US will attempt to find a way to leverage AI for national security purposes. We can also potentially see that the automotive industry will continue developing self-driving cars and getting them to perform better and more accurate. The future of AI will probably see more regulations put in place, and we'll probably see malicious actors start developing their own. On the plus side, the medical industry will surely look into different language models for the different specialties to assist in accurate diagnosing. This concludes Jermaine's and I's presentation on algorithms and AI. We have a few thought-provoking questions that we can discuss throughout the week. The questions are, what are the cybersecurity risks associated with algorithms implemented by AI? What ways does AI pose a threat to job security? And as AI advances, what possibilities of bias are there, and how can they be tied to developers?